Good evening, you all, my dear. I am Rakesh Sharve from Sunbeam Sun City. My dear, yesterday I have uploaded the topics, numerical problems on the topic of real depth, apparent depth, normal shift, lateral shift, and all that. I covered NCERT numericals on that also. Now, today, as I told you, that today I will upload the topic problems on total internal reflection. And I will cover all the questions related to total internal reflection with respect to NCERT numerical given in the exercise also. And my dear, in total internal reflection, we will come across the two spatial concepts, or you can say two spatial body. The one is the total reflecting prism. That you all know in theory that total reflecting prism is working on the principle of total internal reflection. So there will be a numerical on total reflecting prism expected with TIR, total internal reflection, and optical fiber. These are the two questions can be based on TIR. The questions will be there in your NCERT, even on this and even on optical fiber. Now the first question which I have taken, my dear, on TIR is calculate the critical angle. Now you all know that, my dear, here is the answer for first. Calculate the critical angle means you have to calculate IC, because critical angle is the angle of incidence. I hope it is clear. So here I am writing you all for your knowledge, since critical angle is an angle of incidence in the which medium, my dear? In the denser medium. So that is the definition. So what is critical angle? Critical angle is the angle of incidence in the denser medium. It is IC. Okay, now my dear, IC I supposed to calculate. And what will be the diagram for this question? Here I am drawing the diagram. Say this is the glass slab. This is the glass slab. And this is air, right? This is air. This is glass slab. The refractive index, it's not given here. What is the refractive index of the glass? But my dear, I hope you all know that the refractive index of the glass is 1.5. You all know that the Ri of glass is 1.5. Here I am writing that Ri of glass is 1.5. That is, you all know that mu of glass is 1.5. But you all know that mu of glass with respect to air is 1.5. That is Ri of glass. Now my dear, here the light is travel from air medium, and it will be the normal on the glass slab. This can be a normal on the glass slab. You can see. Now this is your angle I. That angle I is your given as 45 degree. It is given that when angle of incidence is 45 degree. And my dear, here is the normal ray, you can see. Now this ray will be coming from air to glass, so it will be bent towards the normal like this. Now since it is bending towards the normal, my dear, so here you can see angle of refraction, that is R. And my dear, here is the angle of refraction. Here is your incident ray. So this is your incident ray. This is your refracted ray. And this angle is I, it is given. The angle I is given. Now my dear, here there is a one word, that is it surface. When a light, if a ray of light which is incident in air on the glass surface is deviated through 15 degree. This word is very important word, that is deviated through 15 degree, deviated. Now what is the meaning of deviated? Let me tell you. That is the light which is incident in air on the glass surface is deviated through 15 degree. Matlab, this refracted ray, this is your actual incident ray. This is the actual incident ray, you can say. Okay, and this incident ray, I am drawing like this, and it is going straight. Yeah, let us draw the straight here inside the glass. Here it is making an angle of I, that is 50 degree. And this is passing here in the glass straight, you can see. Now my dear, here the deviated through 180 degree means this refracted ray which I have observed in the glass, this refracted ray which you observe in the glass here, my dear, this refracted ray is deviated through, because this is your actual incident ray. So this refracted ray is deviated through 15 degree. Here is the 15 degree. मतलब जो रे हमको ग्लास में मिला है आफ्टर रिफ्रैक्शन, ट्राई टू अंडरस्टैंड द लाइन. इफ अ रे of light which is incident in air, this is incident in air, on the glass surface, it will be come for refraction like this. Of course it will be refract towards the normal because it is going from air to denser. But the question is that this light, this refracted ray is deviated through 15 degree. Deviated through 15 degree matlab incident ray ka this is the actual path. This is actual path of incident ray. So from actual path the refracted ray is deviated through 15 degree, you can see. And this is your angle I. This is your angle I which is given as 45 degree. You can see. So now my dear, from figure you can see, from figure, now question is easy. From figure, R plus 15 is equal to I, because this total angle will be your I as vertically opposite angle. Vertically opposite angle. You can see. So now my dear, I am moving it out. I am not actually drawing. You can understand that how the angle I is become, how the angle I is equal to, the R plus 50, because vertically opposite it is. So now my dear, here, what will be the answer? Therefore, R is equal to I minus 15, that is nothing but R is equal to 45 minus 15, that is 30 degree. So we got the angle of refraction as 30 degree. I will put it as equation number 1. Now you all know that my dear, the light is going from, my dear, it is going from air to denser. You all know that. So here it will be mu of glass with respect to air, because light is coming from air going in glass, is equal to angle made in air is I divided by angle made in glass is R. This is sin I by sin R by Snell's law. As light entered from air to glass. Since light entered from air to glass, therefore it is going in glass coming from air. I have applied Snell's law and I got this formula. Now my dear, you all know that this can be written as, in my all step I have done this. This is, let refractive index of glass is taken as mu, and refractive index of air, you all know that it is 1. So this will become, my dear, mu g by mu a is equal to sin I by sin R. I am doing in all this step because you should understand, sir, ultimately this will be mu. So this is mu is equal to sine I upon sine R. But you all know that, my dear, since mu is equal to 1 upon sine IC, you all know that mu is equal to 1 upon sine IC. So now what will happen, my dear? I need to find IC. You can see here. So I got mu is sine I by sine R, but mu is equal to 1 by sine IC by relation. This I got it by relation between mu and IC. We have done this topic, relation between refractive index and critical angle. The formula is 1 by sine IC. So now, my dear, therefore let this is your equation number 2. Let this is your equation number 3. Substituting 3 in 2. So in place of mu I will write 1 by sine IC is equal to sine R upon sine I upon sine, you can see R is how much? 30. That is nothing but sine 45, because I is 45 and sine R is sine 30. So my dear, from here you can see, so what is sine IC? What is sine IC, my dear? Therefore, I am writing here, therefore sine IC will be nothing but sine 30 divided by sine 45. You can see, because 1 by sine IC is sine 45 divided by sine 30. So sine IC will be what? Sine 30 divided by sine 45. Therefore sine IC is equal to sine 30 is 1 by 2 divided by 1 by root 2. Because, my dear, sine 30 is 1 by 2 half and sine 45 is 1 by root 2. So now, my dear, you can see sine IC is equal to, this is root 2 by 2, and root 2 by 2 can be written as 1 by root 2, because it can be written as 1 by root 2, I am sure, because it is root 2 by 4. This can be written as root 2 by 4. Therefore sine IC will become 1 by root 2. Sine IC will become 1 by root 2, and now, my dear, you can say, therefore IC is equal to 45 degree. So IC, the answer for IC, that you can see, the IC is your IC value, because sine IC is 1 by root 2, so IC value is 45 degree. So this is the sum, beta. Here you have to take care of deviated. Please take care of this word deviated through. Deviated means this is the actual incident ray and this is the refracted ray. Actual incident ray से refracted ray कितना deviate हुआ है, that is the answer, that is the value. And therefore, my dear, this question is very good question. Here you can do this method, that sir, R plus 15 is your vertically opposite angle I, that is vertically opposite. So R is equal to I minus 15, and you can do about it. And then you can apply Snell's law where the light is going. So what about this? They have given to confuse. It is not of use. Or if they have given this, I would have find directly. This is not given in the numerical. In this numerical, this is not given because, sir, this is not in use. So it is not given in the numerical. And then, my dear, you can see what you are supposed to do. The question is with the word deviated. So once again, please take care. Deviated means it is the incident ray going straight and the refracted ray is deviated through 15 degree. That is the language here. Okay, but they have not mentioned anywhere that the refracted ray is deviated. But with the word deviated, you should understand that deviated means the refracted ray is actually कितने एंगल से इंसिडेंट रे से अपने पाथ से the incident ray has changed its path by how much angle, that is important. But it is not measured with the normal, it is measured with the actual path of the incident ray and the refracted ray, that is called deviated. This incident ray is deviated from its actual path by 15 degree. That is important statement, and then we can do like this. So this is the first sum which I have done. Let's go to the next sum on it. Now, my dear, let's go to the second question. Question is, these questions are very critical. Critical angle we are discussing, and critical also the question is. And what is the question is? A glass slab is immersed in water. See, try to understand the question. A glass slab is immersed in water, right? Find critical angle at glass water interface. Critical angle at glass water interface, and given the Ri of glass is 3/2 and Ri of water is 4/3. My dear, you all can see, since here there is some reason. Look at the answer. Since Ri of glass is 3/2, that is 1.5, and this is with respect to air. They have given, I told you, whenever they have given like this, you please put air from your side. And glass of water is 4/3, that is 1.33 with respect to air. You all this know. Now from here you can see refractive index of glass with respect to air is greater than refractive index of water with respect to air. It means glass is a optically denser. Glass is optically denser than water. And for TIR, that is total internal reflection, for total internal, this all is a concept, reflection, light must travel from denser to rarer. So now I have concluded, my dear, that the glass is denser and water is rarer. It means the light traveling from, for TIR. So here I will write, this is your concept. This is the concept, my dear, that mu G is greater than mu W from the data. It means glass is an optically denser, is optically denser than water by looking the value. And therefore for TIR, my dear, we know that the light must travel from denser to rarer. Therefore for TIR, that is total internal reflection, light must travel from glass to water. And concept I have given. This is the reason why I have picked up this numerical, which is very important, because you should know actually the light traveling from where to where, because without that you cannot substitute the Snell's law condition. So the light travel from glass to water, matlab it is a Ri of water, because it is going in water, coming from glass. So angle made in glass is sin I divided by sin R. That is angle made in water is R. I hope it is clear, my dear. And my dear, you all know this also. This can be written as mu of water upon mu of glass is equal to sin I upon sin R. This much I know. Right? So first concept is that, sir, light travel from where to where? Glass is immersed in water. Only this much was given. We were not knowing light किस पे incident, पहले water पे आया या glass पे आया. But by looking Ri, I came to know that Ri of glass is greater than Ri of water. Means glass is denser and water is little rarer. मतलब glass is optically denser than water. It means the light will travel for TIR. The light must travel from denser to rarer. TIR का condition है. So for TIR, light must travel from glass to water then, because glass is more denser than water. And hence, my dear, if it is traveling from glass to water, how will you write in Ri by Snell's law? So by Snell's law it will be, this is what is a beautiful concept, rest all is easy. So by Snell's law, sir, it is going in water, so it is mu of water coming from glass, so with respect to glass, and that is equal to sin I, because angle made in glass is I and angle made in water is R. It's natural. So because coming from glass, तो पहले angle glass में बनाएगा, तो I will be angle in glass and R will be angle in water. But mu of water with respect to glass, my dear, I can write this way, mu of water divided by mu of glass. Now the next step, my dear. Therefore, this is mu of water upon mu of glass is equal to sin I upon sin R. Right? I have concluded this step here. Now you know that since when I, your angle incident become critical angle, when I is equal to IC, my dear, that time R is equal to 90 degree. When I is equal to IC, when incident angle become a critical angle of incident, when incident angle become a critical angle of incident, the R become 90 degree. So now here, my dear, this will be nothing but mu of W is 1.33, that is 4 by 3, and mu of glass is 3 by 2 is equal to sin IC. You can see sin IC because I become IC and this become sin IC upon sin 90. Now sin 90 is 1, so it becomes sin IC. So now my dear, what is the value for sin IC? I got sin IC is equal to, here you can see this 2 will go up, this become 8 by 9. 3 3s are 9 and this 4 and 2s are 8. That is 8 by 9 will be written as 0. The value for 8 by 9 is somewhere as 0.8867. 0.8867. This is the value, my dear, and therefore the IC is equal to sine inverse of 0.8867. By looking the logbook, we got IC is equal to 62. The answer for this is logbook mein 62 degree. This is 62 degree 28 minute in the logbook. This is the critical angle, my dear, we have calculated. So the value of IC is 62 degree 28 minute, and this is the way. So this sum I have taken for this reason, so that you should understand that out of this given two medium, which is rarer and which is denser, then only you can conclude that light is going from which to which. Because the question is just given a glass slab is immersed in water. See the critical way of asking the question. So here they have not mentioned that light is fall on water and going in glass, or light is fall on glass and going in water. Please be careful about it. And then I have looking this value, this two value which is given, I concluded the mu of glass is more than mu of water. It means glass is optically denser. जिसका mu ज़्यादा हो ज़्यादा denser है. So glass is optically denser than water, and therefore for TIR the light must travel from denser to air, rarer. So it means it is travel from glass to water. And then I came to know that, oh God, I should write mu as this way, that it is going in water coming from glass, and then rest all is Snell's law. And then substituting I ka value is IC, that time R become 90 degree. This is the definition of critical angle, right? I substituted that, I got the value of IC. So this is, my dear, the second question on the critical angle, on the total internal reflection to calculate critical angle. Well, now, my dear, let's go to the third sum. The next sum, that is sum number 3. You can write here as sum number 3. And the question is, a ray of light is incident on the horizontal surface of the glass slab. So I have taken a glass slab, for example, this way. Here I have taken the glass slab. And my dear, this is called the horizontal surface. Here I have taken, this is horizontal surface. And this is your vertical surface. Vertical adjacent surface. Okay. So now these are the two surfaces, and this is the glass slab. So this is glass medium and this is air medium. Okay, and I have to calculate the refractive index of glass. That mu g is the refractive index of glass, which I supposed to calculate in the question, apart from critical angle also. So data supposed to know that which are the two, but let us draw the diagram, ray diagram first. So a ray of light is incident on the horizontal surface of the glass slab at 70 degree. So here, my dear, say I have drawn the ray of light. it will be bent towards the normal. So I am drawing from here that this is the ray of light. This is incident ray. This is the normal. This is normal ray, and it will be bent. It will be bent towards the normal. It will be bent towards the normal like this. There it is making an angle of I, that is 70 degree. You can see in the figure. My dear, what they said, that I am putting this as A, B. So horizontal surface is AB, vertical surface, adjacent surface is BC, and here I have put D. So my dear, here also, if I draw the normal on this surface, try to understand what is the question given. On the vertical surface, I have drawn the normal. So this is the normal drawn on the vertical surface. This is the normal on vertical surface. And the question is, my dear, here is the angle. No doubt it is a refracted ray. This is the refracted ray. And sir, it is going from air to glass, so it will be bent towards the normal. Here is the angle of refraction bending towards the normal. But my dear, as soon as it will fall on this surface, that is on vertical surface, it become angle of incident with the normal, because this refracted ray is the incident ray for this surface. ये जो refracted ray है, वो ये surface के लिए incident ray बन गया. So with the normal, this ray will make angle of incidence. But here there is a word given in the numerical. There is one very important word is given, my dear, which you are supposed to catch. And what is the word? They have given the word just grazes. This word is very important word. Just grazes the adjacent vertical surface. What is the meaning of grazes? Grazes the adjacent vertical surface. Matlab light after falling here, it will be go like this. That is, it make an angle of R dash is 90 degree. But my dear, this refraction of 90 degree is possible only when this I is equal to IC. That is, on surface BC, the incident ray make an angle of IC. The incident angle on the surface is IC, then only the refracted ray will be grazes on the surface BC. That is, it makes angle of refraction is 90 degree. So my dear, this is very important concept, because you all know theory, that you have done this in theory by your teachers. They have done this theory, and here it is IC. So when angle of incident become critical angle of incident, then refraction angle is 90 degree. You all know in the denser medium this make an angle of critical, I become IC, then R will become 90 degree. We have done this in theory. So this is very important to understand. So now my dear, we have to find two things. To find IC and mu. Mu of what? Glass. We have to find two things, that is to find IC and to find mu of glass. Now my dear, let us do one thing. Here I am giving a name. Say this is a PQ. Here is R. And let us join this triangle. And here I am putting S. I have drawn the two normal, one normal on horizontal surface and other normal on vertical surface. Of course, if I join, because horizontal and vertical are making an angle of 90 degree, so of course this also make an angle of 90 degree, the two normal which are drawn on the two surface. That is horizontal and vertical. Look at the diagram carefully. So my dear, this is also a 90 degree, you can see. So I can say now from figure in triangle QSR, from figure in triangle QSR, all this R is unknown, and unless and until this R is known to me, I cannot proceed, you know. This is very logical. I hope the diagram is clear, everything is clear. So from figure in triangle QSR, once again please take care, this is I-70, it will bend towards the normal coming from air to glass. Question said that it will be fall on the adjacent vertical surface and it will be gauges. It will be gauges. Gauges means, sir, it will be go along the surface. Gauges ka matlab hai it is go along the vertical surface. So if it is go along the vertical surface, matlab if I draw the normal, then this refracted ray is making 90 degree. But this is 90 degree only when this ray, which is a refracted ray for this surface, but when this ray is fall on this surface such that the angle of incident become equal to the critical angle, then only the refraction is 90 degree. Take care. So now what I did, I have drawn the two normal on both the surface and I joined them. If the surfaces are at 90 degree, of course the normal drawn to them is also 90 degree. So from figure in triangle QSR, R plus 90 plus IC, R plus 90 plus IC is equal to 180 degree, because any triangle is 180 degree. So R angle, 90 angle and IC angle is 180. Don't write I here. I is become IC. That's important because I is here. But this I is for horizontal surface. For vertical surface to make angle of refraction of 90 degree to graze the ray along the vertical surface, the I should be IC at this surface. So here in this triangle, this is R plus 90 plus IC is 180. Therefore, R plus IC is equal to 90, and therefore my dear here R is equal to 90 minus IC. R is equal to 90 minus IC. This you put it as equation number 1. Now my dear, you can see since light travel from air to glass, so by taking refraction on surface AB, since light travel from air to glass, so by taking refraction on the surface AB, because there are two refraction takes place, on the horizontal surface the refraction takes place and on vertical surface the refraction takes place of 90 degree. So first refraction I take it on AB. So when I take the light from air to glass by taking refraction on surface AB, so by Snell's law, my dear, I think you are knowing what is the Snell's law here when I apply. So when I apply Snell's law here, the light going from air to glass. So here it is mu of glass coming from air is nothing but sine of I divided by sine of R. I hope it is clear. And my dear, here I said, since this can be written as, every time this I am writing, mu of glass with respect to air is mu of glass upon mu of air. Let mu of glass is taken as mu and mu of air is 1. So mu of glass with respect to air is mu. I hope it is clear, because mu of glass with respect to air is mu of glass upon mu of air. So many times I have written this. And let mu of glass is mu and mu of air is 1. तो मेरे को क्या मिलेगा बेटा? मेरे को मिलेगा mu of glass with respect to air. mu of glass के जगह पे mu of air के जगह पे 1. So mu of glass with respect to air is mu. So now here my dear, this will become mu is equal to sine of I divided by sine of R. R is 90 minus IC. Because R is 90 minus IC, you can see. So my dear, here I will get mu is equal to sin I, that is sin 70 divided by, because I is 70, divided by this is cos IC. Because sin of 90 minus IC, since sin of 90 minus IC is equal to cos IC. So now my dear, I got the value of mu as sin 70 divided by cos IC. So from here I can say, so now from here I can say, my dear, therefore what is cos IC? So cos IC is equal to sin 70 divided by mu. This is my, say, equation number 2. Cos IC is sin 70 divided by mu. Now my dear, I don't know rest all any value. I will leave here. Now let us go on the refraction taking place on the other surface. This is the first refraction taking place on the horizontal surface. So now by taking refraction at surface BC, by taking refraction at surface BC, you can see refraction at surface BC is I has make an angle of critical angle. I is critical angle here, right? Because R is 90 degree. So if you use that formula by Snell's law, what I'll get? Light going from glass to air. Light going from glass to air, because this is glass and it is going in air. This refraction gauges air. I have told in my theory class that this is incident ray in glass for this surface. But this is a refraction ray, no doubt it is coming on the surface of glass only, but this is rarer medium. So here light going from glass to air, so the refractive index of where it is going in air, from where? Glass. So it will be, my dear, mu of air upon mu of glass. Try to understand. Now this will be nothing but sine what is made in glass, because here the light coming from glass. So glass में angle क्या बना है? Sin IC divide by air में angle क्या बना है? R, that is sin R dash. So this is sin IC upon R dash, that is sin 90. So this is ultimately sin IC. But my dear, here try to understand, this is mu of air upon mu of glass. You all can see, this is mu of air upon mu of glass. So now my dear, you all know that if mu of air is, since mu of air is 1 and mu of glass is mu. So what will happen here? This will be, I am writing here, I am removing this diagram. So here it will be nothing but, this is a very good question. So here my dear, you can see mu A is equal to 1 and mu G is equal to mu. Therefore, G of mu with respect to A, which is mu A upon mu G, here I am concluding, and I got this as sin IC. So this is 1 upon mu is equal to sin IC, because you know mu A is 1 and mu G is mu. Therefore, sin IC is become 1 by mu already given. Now my dear, here I wanted to tell you one thing. Your book has given directly the formula. Okay, we know that the critical angle on Ri is having this formula. So for BC surface which I have taken, where the critical angle for which the angle of refraction is 90 degree, my dear student, sometime write directly the formula. But in case if you don't know how it is coming, I have solved it. I have solved it. This is when refraction takes place on BC surface. This is when refraction takes place on BC surface. And this is what the way I am getting. You can see from here. This is entire, I have done the calculation that how the answer is coming as 1 by mu is sin IC. So in the exam, if you feel that you have knowing much, so you can avoid all this and you can write directly the formula. We know that 1 by mu is sin IC. So now my dear, this I will put it as equation number 3. So now you can see equation 2 and equation 3. Equation 2 is cos IC is equal to sin 70 by mu, and equation 3 is sin IC is equal to 1 by mu. So my dear, dividing 3 by 2. So when I divide 3 by 2, what I will get? When I divide 3 by 2, what I will get? That is important. So when I divide 3 by 2, my dear, so here it is sin IC upon cos IC is equal to sin 70 by mu upon, sin IC is 1 by mu and cos IC is sin 70 by mu. So mu and mu cancel, the answer will become 1 by sin 70. I hope it is clear, beta. You will get 1 by sin 70. Now my dear, this is tan IC, because sin IC upon cos IC is tan IC, and this is 1 upon sin 70. The value of sin 70 from log table is 0.9397. That is sin 70 is 0.9397 by log book. I am writing from where I am getting by log book. So my dear, here tan IC is equal to, if I reciprocate this is 1.0642. Now my dear, you all know that tan of 45 degree is 1, but it is 1.06, matlab more than 1. So answer will be more than 45 degree. So this implies IC is equal to tan inverse of 1.0642, which will give me the answer of IC as 46 degree according to logbook, 46 degree 47 minute. This is, I calculated the value for IC. So critical angle is solved. And how much is the critical angle? Critical angle is 46 degree 47 minute. I got the answer. Now my dear, the second step is to find my dear mu. That is mu of g. That is mu of g is nothing but mu, na? Because mu of g is mu. So now here you all know that since mu is equal to 1 by sin IC, because sin IC is 1 by mu. So if sin IC is 1 by mu, so mu is equal to mu is equal to 1 by sin IC. So this is mu is equal to 1 upon sine of IC is, I got IC as 46 degree 47 minute. So this is mu is equal to 1 upon sine of 46 degree is 0.7, I think it is 0.7688. It is 0.7688. And therefore, my dear, when I calculate this, reciprocate this will be 1.372. So I got the value of mu, and again, my dear, this reciprocal also you will calculate by logbook. By logbook. So this is all, my dear, from my side on the third sum on the critical angle, which is very important. Please try to understand the sum as a gauges, vertical and all. And this step which I have done earlier, that when it will be taking a refraction at the surface of BC, how this formula is coming. No doubt we already derived these questions because this is a derived formula. So sometime, my dear, as soon as the surface BC is coming and there the refraction taking place of 90 degree, grazing on the surface, matlab refraction is taking of 90 degree, my dear. It means I is incident angle on that surface become critical angle, and you can use directly a formula that relation between mu and critical angle as sin IC is 1 by mu. Or in case, beta, if you have struck somewhere, you derive yourself, get this value, and then just go on taking the ratio of sin IC and cos IC and get the value, everything. So my dear, here I will stop, and then the many more questions are left out, which I will do in my next video on the same topic, total internal reflection. There are many numericals which are very important with the exam point of view. Thank you and Jai Hind you all.